we are just looking at this code folder where we have several codes. And in the last lecture, we started with these assembler directives, then assembler directives for .exe mode, and then assembler near and far function calls. So this is what we have covered in the last lecture. So from the last lecture, we are aware that a program can be written in both of the modes. In higher level languages like C, C++, Java, Python, etc., we do not need to bother about which mode we are using for writing our programs, right? But when we are programming in assembly, we need to take this into consideration. So whether you want to use a separate space for data segment, code segment, stack segment, etc., that you should be very clear when you will begin the program. But for understanding purposes, I mean for learning the programs, we will be mostly making the programs in .com mode, and in the laboratory sessions you will be making the equivalent .exe mode programs also, right? So this was what we covered in the last turn, and in today's lecture, okay, let me just start recording also. Yeah. So this was what we have covered in the last turn: assembler directives for COM mode, exe mode, the near and far function calls. And in today's lecture, we are going to cover arrays, how to define arrays inside your 8086, then how to define your string printing program. If you want to take the if you want to give the output onto the screen as something, that's what we are going to see, and that will be very helpful for making our programs interactive. And similarly, we will learn how to define macros. I'm sure you must be aware of macros from your C programming language, where if you are using few lines of codes frequently and they have certain arguments with changes, so macro can be used there. Macro is just like function. The only point is it is not called. It is not called, and the program does not jump its control from one location to another. Only those 3 or 4 set of lines which are included in macros, they are inserted at that place in the code. So we will talk about this macro also today, and we will see a working program of macro. And then finally, we will see how many interrupts are available in 8086 and what are their properties. So one very important thing is in 8086, you will have all vectored interrupts, right? All vectored interrupts are there. So vectored, I mean, they will all have some addresses. They will all have some addresses which are predefined. So user does not have to supply any address for being able to implement this interrupt. So this is the program for today. We are going to learn these 4 things. So I'll start one by one. So first of all, we are going to study the program for how to create arrays inside 8086. On the last turn in the laboratory, I have also given you one program where as homework, where you were supposed to implement an addition, subtraction, or a multiplication of 2 different arrays which are 2-dimensional in nature, right? So this program might come handy there, because here you are going to use assembler directives, and that facilitates the accessing of address of arrays and creation of arrays, etc. So this assembler directive that I am going to discuss today is going to help you in that case, right? So this is introduction to arrays, and we are writing our program in .com style. .com style because it is easier to work with .com style. You don't have to use separate segments for everything. So everything that you use, code segment, extra segment, data segment, it will be treated as the same 64 kilobyte section. It will be treated as the same 64 kilobyte section. So that way I am making my program, and if you want to make it in .exe mode, you can make changes accordingly, because you are already aware of how to convert a program to exe mode from the previous lecture, and we will do that in the laboratory, right? So since it is a .com style program, it will always start from org100h, right? So this is the signature of a .com program, org100h. Then now I want to define my data segment. So in these 2 lines, I have defined my data segment. So first of all, what is the kind of data that I want to create? So here I have mentioned in comments also, syntax to declare an array of 5 elements. We are going to declare an array of 5 elements, and named num1. The name of the array will be num1, right? and every location is a byte. Of course, every location will be byte because the externally interfaced memory is such that every location is a byte there, right? And the default value filled is 88H. Obviously, when you are going to create an array which will have 5 elements, you need to initialize it with something. Otherwise, it will contain some garbage value. So it can also contain some garbage value, but we want to initialize it with 88H. Every location should be initialized with 88H, right? So for initialization, in place of H, we may also use B for binary, D for decimal, and O for octal, right? So this is something that we are already aware of. So if you want to initialize it with any representation, you can do that. The only thing that you have to keep in mind is it should be 1 byte only. So I have initialized it by 88H here. Then to initialize by garbage values, use question mark in small brackets shown in the syntax. So I will talk more about it in a while. So this is the problem statement for defining an array. We want to have 5 elements and all of them should be initialized with 88H, right? So here what I have done the same thing in these 2 lines of code. So dot data will mark the beginning of my data segment, and here I am defining my array, and you can see that num1 db means define byte. Num1 is the name of the array, db means define byte, right? So every element of this array will be of 1 byte. And how many locations should be there in array? How many elements should be there in array? So this is what I have defined here. There should be 5 locations in my array. And DUP means duplicate. DUP means duplicate, and in small brackets I have written 88 in hexadecimal. So what does that mean? Num1 will be the name of array. Every location will be of 1 byte db, and 5 such locations will be created. 5 such consecutive locations will be created, and DUP means duplicate with 88H. So all such locations will be filled with 88H. So in this way, my array will be created, right? So this is my data segment, and here the array has been created. And now inside the main program in the code segment, I am trying to write the code for accessing the 4th element of my array. And remember the numbering in 8086, it will start from 0. So 0, 1, 2, 3, 4, right? So I'm trying to access the 4th element. 4th element will occur at index number 3. So indexes, they start from 0, 1, 2, 3. And 4th element will therefore mean the 3rd indexed element. That's what I want to access, right? So here I have started my code segment by dot code. Then there is this main procedure. Main stands for beginning of your main program which will be executed. PROC means procedure. It is an alternate name for function. So main function is this, and then you have to somehow end this main procedure somewhere, main end procedure. So this is the ending of that. And return means after executing this main program, the control will be returned to the operating system. So that is why we write return statement here, right? And in these 2 lines of code, what we have done is LEA. LEA command stands for load effective address. Load effective address. What is the effective address? The effective address means the offset address that you are talking about, right? So here inside SI, the effective address will be moved. And effective address of what will be moved? That is written after this comma. After this comma, whatever is written. Num1 plus 3. Num1, what is num1? Num1, as we have just defined here, num1 is the name of the array, right? So the name of the array is also the address of its very first location, or the index 0 location, right? So num1 plus 3 will take me to the 4th element of the array, 0, 1, 2, 3. So 3rd indexed element or the 4th element of the array. So num1 happens to be the address of the index 0 element or the first element of the array, and num1 plus 3 will take me to the 4th element of the array. So the effective address of that is loaded into the SI register, and then you know how to change the value at that location. So at that location, I want to put 41H. So I have simply used move in brackets SI. So at the location num1 plus 3, the address of num1 plus 3. At the address of num1 plus 3, the 41h will be written there, right? And rest every location is already pre-filled with 88h. So this is a very simple program for creating an array. And let us see this program at work. So let me emulate this code and let's see if this works according to our conceptualization or not. Okay, so my system has hanged, so let me just restart this. Okay, till then, if you have any doubts about this array program, you can ask. Wait a minute. So let me just see what happens here. Any doubts in this program? Still not visible here. Yeah. So till the this 886 simulator starts, I don't know what has happened to my computer today. It has just hanged. Yeah. So let us see this program at work. Okay, so no problem. Till then, till the time my 886 emulator is not running, we will try to understand the programs on Notepad. Okay, just give me 5 minutes. I'll just fix my computer and then I will be back. Okay, till then, since my computer is not working, till then all of you can see that lecture that I have already pre-recorded for this topic. I have pre-recorded that lecture. I will give you the number of that. The title of that lecture is interrupt. So it is already kept inside your folders, microprocessor and microcontroller. So it is lecture number 16, video lecture number 16. So please see this video lecture number 16 since my computer is hanging randomly. Okay, so it is now running fine. Again it has started to hang. Please see video lecture number 16. We will discuss then in the laboratory. I'll put this on your WhatsApp group also.